In this lecture, we will discuss about the bending loss. Bending loss caused by two types of bending. One is macro bending, and another one is a micro bending. So, what do you mean by macro bending? So, macroscopic bendings having large as radius are larger as compared to the fiber diameter. So, we can say microbending losses occur when the curvature of microscopic band, here band is macroscopic band is much larger than the fiber diameter. So this is the curved diameter, this is R, R is the diameter. So if the curvature of band is greater than the fiber diameter, then this type of loss will occur. And as the radius of curvature decreases, the loss increases exponentially and at the certain critical reaches up to maximum at the certain critical radius. So basically, when this type of loss occurred, then the optical fiber no longer support the total internal reflection for the few rays. There is total internal reflection inside the optical fiber, but for few rays, total internal reflection is not supported, and few of the light refracts and power is lost. And this type of phenomena can be easily explained by the Bohr theory. So in case of microbending losses, so this is more severe for the higher order mode. This is more severe for the higher order modes as compared to lower order modes. Here, what is the XC? XC is this is the axis of fiber, and this is the radius of fiber, and this at XC, suppose we are measuring the power loss through the radiation at this point, and this is the field strength at this point. So higher order modes are less tightly bound to the fiber, so they can radiate easily as compared to lower order modes. So this is about the microbending losses, and this is showing this solid line showing the field distribution with respect to this axis. Now next is microbending. So what will be the cause of microbending? Microbending is caused due to manufacturing defect. So in this, when optical fiber incorporated into the cables, so at the time of manufacturing or installation, there will be small scale fluctuations and along the fiber axis. So that will cause the micro bending. So basically, this is because of the non-uniformity, and second, this is also caused by the non-uniform lateral pressure created during the cabling of fiber. When the fiber is cabled, then pressure from lateral pressure create this type of band. Here you can see two diagrams. The first one is showing the loss from the higher order modes, and this is the power coupling inside the cable. So next, this is all about the bending, macroscopic bending and microscopic bending. So in macroscopic, radius of band curvature is greater, and microbending is caused due to the manufacturing defect. So this is all about the bending losses. Next, we will discuss about the dispersion in the optical fibers. And what do you mean by dispersion? Dispersion is a phenomena in which velocity of propagation of any electromagnetic wave is wavelength dependent. So dispersion is caused when the propagation is depend on the wavelength. In communication, dispersion is used to describe the electromagnetic signal propagation in a physical medium, and the velocity of signal, different propagation velocity within the physical medium is measured, and then it is observed that the signal is degraded while the propagation. So in next class, we will discuss in detail what do you mean by dispersion, what is the cause behind dispersion, what are the different types of dispersion, and how we can overcome this dispersion. What are the preventive measures that can be taken to avoid the dispersion in optical fibers?